We found the 3 torques, they added up to 0. It matches what I was expecting.
So
Hopefully, it matched what you were expecting. Genesis?
if the circle didn't have a dot in it, would that mean that it's away?
Away is the cross. So dot is toward you, and that is away from you. Sometimes referred to as out of the board and into the board. So if you shoot an arrow away from you, you see the feathers. I know arrow feathers don't look like that, but that's the memory trick.
Do you get to choose which one would be positive and which one's negative? Or is towards you always positive?
Once you establish I hat, J hat, that you are, that establishes the direction of K. If it were truly a one-dimensional problem, you could get away with just saying, I'm gonna make that way positive or that way positive.
Can you do it again, making it negative?
I'm gonna do one other thing first.
Okay.
I'm probably gonna forget, so remind me. All right, I'm gonna look at this slightly differently. Using my I hat, J hat coordinates over there, that to the right is positive and up is positive. In the first case, my first torque would be, well, it's a vector point going to the right. So that's 0.2 times a force which is going up, 0.5, plus, if I go to the next one, I have my R hat is going to the right, 0.5 meters. And my force is going down, -1 Newton. Plus, the last one, my moment arm is going to the right, so 0.8. My force is going up, 0.5. And we get the exact same result. That negative here comes out of the fact that that's negative. So if I choose the standard coordinate system, it'll work out that way as well. So side note, in the lab, that's what happens. I just say make to the right and up positive, therefore to the left is negative, down is negative. Maybe.
Where did you get 8.8?
I said the whole thing was 1 meter long, and that this force was 0.2 meters from the right side. Therefore, that has to be 0.8 meters.
Okay.
It's, I guess, easier on the meter stick because you'll establish the position is at 80 centimeters. Other questions? Oh, you wanted to switch it around?
I know I'll come to the same thing, but it would help.
So if we established, just for the sake of it, so let's ignore that. We'll make I hat positive that way, J hat positive that way, and so therefore K hat is into the board. I'm gonna add up the torques, it should be close to 0. So the first one here is trying to rotate, if that's my axis right there, it's trying to rotate it this way, which is out of the board. But we said into the board was positive. So out of the board would be negative. So it's negative 0.2 times 0.5. And then the next one, again, this is my axis here. It's trying to rotate, the weight is trying to rotate it like that. So that way, so into the board. So that would be a positive torque. So plus 0.5 times 1. This is R and F. And then the last one, if this is my pivot point, this last force is up. So it's pulling it around like that, out of the board. So negative direction, because of the way we've defined it, 0.8 times 0.5. And it'll add up to 0 still. Is that what you were looking for? Okay. Other questions before we pick a different axis of rotation? All right, let's do it. I'm gonna get a clean look here. Let's see, so. And I said 0.5 newtons, 0.5 newtons, 1 newton. And my distances to the first one was 0.2 meters, to the next one was 0.5 meters, and then the next one, 0.8 meters. And we're picking, the middle as our axis of rotation. We're still gonna go through and add up our 3 torques. This one of the torques is incredibly simple. I'm gonna go with the more brainwashed to the right, up, out. This is my coordinate system. So I go through, I'm gonna add up my torques, they should add up to 0. So I got this point right here. This is pushing up. Is this positive torque? Is this trying to create positive torque or negative torque?
Negative.
Positive.
It's one of those two.
Which,
This one right here.
if it's positive, negative, positive.
We're now 2 and 2.
You said we're doing the I hat, J hat, where it's positive, right? Where the arrow is pointing at us.
Positive K hat is towards you. All right, so we've got, now the pivot point is in the middle.
Oh.
This force is acting up. It's trying to rotate it that way. Thumb points into the board. That would be negative. So congratulations on those who said or thought negative. And thank you for those who said positive for playing. I do appreciate it. So for my first torque, I've got R, which is 0.3 times a force of 0.5, it is negative, plus, what is the torque from the weight? So let's go back to this. I got my pivot point right there. Which way is weight trying to spin it? The weight is acting right there. Which way is the weight trying to spin this thing?
Nowhere.
Nowhere. So the moment arm is 0, because if I did a force from my pivot point to where the force is applied, it's 0. So no torque is actually being applied by the weight. And then this last one, positive torque or negative torque. Again, my pivot point is now here. Yeah, it's trying to rotate it around like that. Better be positive because I need to get 0 at the end. So plus 0.3 times 0.5, and I end up with 0. Negative 0.15 plus 0 plus 0.15. Alternatively, if I'd gone with just what I started with the I hat, J hat, positive right and up, my first moment arm is a vector pointing that way. So that is negative 0.3 I hat, for those who want to be really official, times 0.5 J hat, plus 0, plus Well, the last moment arm is for my axis of rotation to where the force is applied. That's going to the right. 0.3 I hat. Technically cross 0.5 J hat. Well, I know I hat cross J hat is K hat. So I have negative 0.15 K hat plus 0.15 K hat. 0. Yes, Jason.
0.3?
Where did I get the 0.3?
Yeah.
If I take a vector from my axis of rotation, which we're assuming is in the middle now, to where the force is applied, I know this distance from here to here is 0.2 meters.
Yep.
And that's 0.5, so.
Yep.
0.3.
Thank you.
Not drawn to scale. All right. Any questions now? Well, I'm about to make it look more complicated. I assume that's a smile, because you're looking forward to it. Okay, so let's set up new situation here. I got my beam. Now, it is helpful. I know that when I'm doing torques, I get maximum torque if they're at a right angle, if the moment arm and the force are at a right angle to each other. So I know that my weight is acting straight down. These are acting up because of just the way the mechanism works in lab. If the beam here is level, that is a right angle and I can just multiply. If I did it with the beam at an angle like that, I'd have a force up, I'd have, my moment arm would be pointing from my axis to where the force is applied. If I just multiply them, I'm not gonna get the right actual torque. It is far more difficult to do that. For 151 and 251, I would expect them to be able to handle it. For 110, I would expect you to know that it's not, the torque is less than just that distance times that force. But actual calculation of it requires trig. I'm not subjecting you to that. Unless, again, those are just General Bronswell's ring and trig. I have a couple people shaking their head no. I say all the people who did not respond want trig. However, I will go with the head shakes. Let's make it 1.2 newtons. I'm gonna make that 0.5 newtons. I'm gonna make that make that 0.7 newtons. My force is up equal to force is down. That part holds true. Except I need to give some distances here. I'm going to say that this is still 0.2 meters. I'm going to make this still 0.2 meters. I'm going to make the whole length 1 meter. But what I don't know is where exactly is the center of mass of the meter stick. That's my unknown. I'm going to use some clever letter like X to represent that distance. I don't know where the center of mass is. I gave you the distance from the left edge. But I can choose, since it is in rotationally static equilibrium, yet a third different way I've said that. We can pick any place to be our axis of rotation. Where do you want to pick?
The middle.
I heard the very smack dab middle. So at, you said no? Oh. All right. So I assume half the middle of the meter stick. Again, I don't know what X is. just for the sake of what we're doing right here, I am gonna make the assumption initially that x is bigger than 0.5. That I'm gonna go with the way I've drawn this, and so my axis of rotation is here. If I am wrong, then I will, well, it's gonna come out. That whatever answer I get for x, if it's less than 0.5 or greater than 0.5, it'll work out. Sorry. We'll talk about a simpler way in just a moment. I'm gonna add up the torques. I have 3 forces, none of them hitting at my axis of rotation. So I'm gonna have 3 numbers. My first force is here, going up. Is that trying to rotate it in the positive or negative direction? Negative. Because it's trying to rotate it that way. I know my total torque is 0. The sum of torques is 0. And so I've got negative, well, that distance is going to be 0.3. Because I heard the middle, so that's 0.5 from this end, that's 0.2 from this end, so it's 0.3. So I have a distance of 0.3 and a force of 0.5. Thus, the weight, which way is that trying to swing it? Positive or negative torque?
In the middle?
It's not in the middle.
Just trying to swing it positive.
So that's the pivot point right there. I drove my weight over on this side. It's trying to rotate it. Trying to rotate it clockwise, yes, into the board. It'll also be negative. The distance, and this is where the math comes in to make it a little bit trickier. The distance is whatever the difference is. It's from my pivot point to where x is. So this distance right here, that tiny little distance the way I've drawn it. So it's gonna be x minus 0.5. Because I know from here to where the force is applied is x, from here to the middle is 0.5, and so the difference between them, x minus 0.5 times the weight, which is 1.2. And then the last one. Again, thinking of the middle as my axis of rotation, which way is that 0.7 Newton force trying to rotate it?
Positive.
Which way? I heard somebody say something.
Positive.
Positive, yes. So the distance 0.3, and then a positive, is it 0.7? 0.7 equals, should equal 0. So now we're left with this problem right here. We've got to do some math. Well, this one's simple enough. Negative 0.15 plus, we'll come back to that, plus 0.21. This bit right here. Bring back some fond memories, I'm sure. If I've got, this is known as a binomial because I've got 2 terms, times a number out front. How can I simplify that? That's the word. So I multiply this times that, and this times this. Don't forget I got a negative up front. So that's negative 1.2x plus 0.5 times 1.2. The negatives cancel out, that's why that's positive. Let's see, so I need to get X all by itself. Well, that right there is 0.6. So I got negative 0.5, 0.6, and 0.21. And negative 1.2x plus 0.81 minus 0.15, 0.66. And then I need to get, separate, I need to get X by itself. So I'm just gonna bring this over. Negative 1.2x equals negative 0.66. And then I need to get X by itself, so I gotta get rid of that negative 1.2 by dividing. Whatever that is. Something bigger than 0.5? 0.55? Units? Sorry, different.
Fine.
Yes. It's a distance from the left end. Was it 0.55 even or did 0.5 repeat?
Oh, I had 0.55, right?
Just the 2.55? Okay. Questions to hear?
Can you explain why the first portion is negative again? Like with your hand
Why this is negative?
before that? Yes.
Why that's negative?
Mhm.
So I'm looking at this, trying to figure out whether it's positive or negative torque. So again, I imagine I've got my axis of rotation in the middle. That's pushing up this way. So it's trying to rotate it around like that. So on the meter stick, we chose the middle as our axis, and we're dealing with a force over here, trying to rotate it like that. If it's rotating like that, rotating around like that, thumb points into the board.